Right, so the first step is to factor. So we're going to factor the numerator and the denominator. So what are numbers that add to a 2, multiply to a 2, add to a 3, that's going to be x plus 2 and x plus 1. Your denominator needs to multiply to a negative 2, but combine to a positive 1. That's going to be x plus 2 and then x minus 1. So these are not called reciprocal functions. These are called rational functions. It's a fraction. And you've got x's everywhere. And what's happening with this rational function, the numerator and the denominator are constantly fighting. Whatever's happening in the numerator is totally affecting what's happening in the denominator and vice versa. So after you factor, you got to see if there's a hole. And there is a hole in this graph because I have an identical factor on the top and the bottom. So I'm grabbing my asymptote pen, and those cancel out. Remember, the top and the bottom are competing and fighting against each other. If they both have the same thing, we don't even need that in there because it cancels each other out. So we're going to have a hole. I know the hole is going to occur at a negative 2. That's the x coordinate. And I know there's a hole at negative 2 because if I did not cancel that out and I knew that x was negative 2, what would happen when I plug in a negative 2 right there?
It's the same thing.
Yeah, it would cancel it out. We broke the rule. We would have a 0 in the denominator. So we have a hole in the graph, and I'll show you what that looks like. All right, so we have a hole. And remember, there's no rear view mirror in math. You never look back on your previous work. When this stuff cancels out, you're going to have x plus 1 on the top, x minus 1 at the bottom. So now to find that y coordinate, y'all, I just plug in negative 2 into my line of work here. So I'm going to plug in negative 2 where the x is. So my y coordinate is going to equal negative 2 plus 1 over negative 2 minus 1. So do your order of ops. Negative 2 plus 1, the top is going to turn into a negative 1. Your bottom is going to turn into a negative 3. So that negative 1 over negative 3 is going to be a positive fraction. So write positive 1/3 right there. All right, so let's go back and figure out what we got for our steps. We have factored. We have identified a hole. Now we're moving on to vertical asymptotes. Yes. For the hole. Because if I plugged in negative 2 for x value in the bottom, it would make that a 0. Yes. Yes, you analyze what cancels out, and since it was in the denominator, we don't want that in our graph anyway. That's not going to be part of our input. I feel like I also want to say something else. Good question. Any other questions?
Why didn't you switch the signs for the 1/3, but then for the 2 you did?
So I did not switch the signs for the 1/3 because I was just figuring out like where the hole was on the map. And the reason why I did change that to a negative is because if it would have been a negative 2 there, it would make this cancel out into a 0. So when I say hole, I mean a literal hole. If you look at across, y'all see the graph? Y'all see that little X? Y'all see the X? Y'all, that's negative 2 1/3. That's your hole. And that is a horrible picture. I hate the way this picture looks. It should look like this. Like you should be able to see through it. So we can't have that as part of our input. Why can we not have that as part of our input? Because we can make the denominators. It'd make the denominators 0. And we plugged it in. We plugged in negative 2 just to find out where it was on the graph, to find the y coordinate. Okay, So let me kind of, y'all, I gotta erase this stuff as I go because I want this all to be on one page. All right, so we have knocked out holes. Let's look for our vertical asymptotes. Same exact process as yesterday. It comes from the denominator. So what's left over here? What would make that equal 0? A 1. So that's your vertical asymptote. So we're going to write x equals 1. Yes, Jacob?
Are we doing it from like the top fraction or the bottom?
No rear view mirror. You always work on your current line. Whatever your latest work is. Whatever your latest work is, that's what you're working on. Okay. Now that I tell Jacob that, I'm going to backtrack for a moment. This is my favorite part of this whole concept. This is the horizontal asymptotes. The horizontal asymptote, remember in a minute, the top and the bottom are fighting. They're competing. To figure out the horizontal asymptote, you have to look at the degrees. If the degrees are higher on the top, then the numerator wins, and there's not going to be a horizontal asymptote at all. If most of the degrees are at the bottom, then the denominator wins, and then the horizontal asymptote is y equals 0. If neither one of them win the degree fight, which is the case here, you have to be the judge and figure out the horizontal asymptote all on your own. All you got to do is divide the leading coefficients. Do y'all even remember what a leading coefficient is?
No.
It's the A value. Y'all look up here. What's the A value of this top part?
1.
Yeah, it's understood to be 1. What's the A value of that? 1. Yeah, you just do 1 divided by 1. A divided by A. So this is going to have a horizontal asymptote of y equals 1. And I am going to explain all that in detail again. All right. So we figured out what our horizontal asymptote is. The next is the zeros, which is the x-intercept. This is not like the reciprocal function that's used. The x-intercepts are from the numerator. Look at the numerator. The numerator is x plus 1. What would make that a 0? What would x be? That's it. Then your x-intercept is negative 1, 0. Remember, that comes from the numerator. Okay, the y-intercept is exactly like yesterday. The y-intercept, you're just going to plug in 0 and do your order of operations, but you have to plug in 0 everywhere you see the letter x. So to find the y-intercept, it's going to be 0 plus 1 over 0 minus 1. And just do your order of operations. So the y-intercept is negative 1.
How do you find the x-intercept again?
From the top, from the numerator.
And then just the opposite of the numerator?
What would make it 0?
Oh.
Yep. Okay. And don't worry about trying to remember all this again because we're going to do it. We're going to do it all over again. Okay, the domain. For the domain, initially, let's just look at the graph, y'all. So if you look on the other side of your page, you have this graph. And I'm going to write the domain in different colors, then I'll go back and explain it. So the domain, which is what you're going to put on this last line, I'm just going to show on this screen. Your domain is going to be negative infinity to negative 2, or negative 2 to 1, or 1 to infinity. Let me go back and highlight how I know that. So this first piece that I wrote in yellow right here, remember the domain are the inputs and you read them from left to right. The inputs start right here. That's a negative infinity symbol. This graph goes, boom. It stops right there at the negative 2. But it doesn't stop forever. It picks right back up on the other side of negative 2. And then it goes. And remember, it gets as close as possible, mathematically possible, to the vertical asymptote, but it never touches it. So we also have a branch over here, so I need to go to the other side of the vertical asymptote. And then it picks up as close as it can to the -1, and it goes forever. So, like what Amina said earlier, your vertical asymptotes you do put in your domain because you're excluding them. But now you also put your holes. Whatever your x-coordinate is for the hole, you have to put that there. Why are we excluding -2? Why are we excluding
The whole.
Is equal to 0.
How do we know it's a hole? Because it canceled out. But what would happen if we had an input of -2? The whole function machine would blow up. What else did we block out? We blocked out a +1. If I had an input of +1, the whole machine would fall apart. That's all the domain is.